Have you ever looked up at the stars and wondered what's holding the universe together? Have you ever gazed at the intricate patterns of nature and marveled at the forces that shape our world? Today we're diving deep into a topic that's both inspiring and thought-provoking. We'll explore the invisible force that holds the universe together, a concept that has puzzled scientists and philosophers for centuries. But before we dive into this mind-bending mystery, we've got a question for you. What do you think is the force that holds the universe together? Is it gravity, electromagnetism, or something more mysterious? Share your thoughts in the comments below. Your ideas might just surprise us. Now let's embark on this enlightening journey. The first thing we have to understand is that the universe is full of matter, energy, and forces. Everything we see, touch, or feel is made up of tiny particles that are in constant motion. These particles interact with each other through fundamental forces like gravity, electromagnetism, and the strong and weak nuclear forces. Gravity is the force we all know pretty well. It's what keeps our feet on the ground and what makes objects fall when we drop them. But when it comes to holding the universe together, gravity alone can't do the job. Yes, gravity does play a significant role in the large-scale structure of the universe. It's the reason galaxies form and planets orbit stars. However, on a subatomic level, gravity is too weak to be a fundamental force. It's like trying to use a tiny eraser to fix a broken vase. It just doesn't work on that scale. Electromagnetism is another fundamental force that has a huge impact on our daily lives. It's responsible for everything from the light we see to the electricity that powers our devices. But like gravity, electromagnetism can't hold the universe together at its most basic level. While it's crucial for chemical bonds and atomic structure, it falls short when we zoom out to consider the universe as a whole. So if gravity and electromagnetism aren't the answer, what else could hold the universe together? To find the answer, we need to look even deeper into the world of fundamental particles and the forces that govern their behavior. Enter the strong nuclear force. This is where things get really interesting. So the strong nuclear force is one of the four fundamental forces of nature. It's what holds the nucleus of an atom together, binding protons and neutrons despite the natural repulsion between them. The strong force is so powerful that it's the strongest force we know of in the universe, but it only works over extremely short distances. Think of it like a superglue that's incredibly strong but only within a few atomic layers. Here's the amazing part. Some physicists believe that the strong force could be the key to understanding dark matter, one of the most perplexing mysteries in modern physics. Dark matter is a hypothetical form of matter that makes up a significant portion of the universe's mass, but it doesn't interact with normal matter or light. This makes it invisible to telescopes and other detection methods we typically rely on. Scientists have inferred the existence of dark matter through its gravitational effects on galaxies and galaxy clusters, but its true nature remains elusive. One intriguing idea is that dark matter could be made up of exotic particles held together by a strong force. If true, this would mean that the strong force plays a much larger role in the universe than we currently understand. It's like discovering a new type of glue that holds the galaxies together. But the strong force isn't the only thing that could play a role in holding the universe together. There's also the vacuum expectation value, or VEV, of the Higgs field. Let me explain. The Higgs field is a theoretical field that permeates all of space-time. It's related to the Higgs boson, a particle discovered in 2012 that was the last piece of the standard model of particle physics to be found. According to some theories, the Higgs field has a non-zero value, meaning it's constantly present, even in empty space. This non-zero value, known as the vacuum expectation value, or VEV, could provide a kind of scaffolding that gives rise to mass and holds the universe together. It's like the background radiation that fills the universe, providing a foundation for matter and energy to interact. The idea of the Higgs field and its VEV is still highly debated among physicists. It's one of the leading explanations for how particles acquire mass, but there are still many unknowns. Some physicists believe that the VEV of the Higgs field could also play a role in holding the universe together. But this remains an area of active research. Now, here's where things get really mind-blowing. Some physicists speculate that the force that holds the universe together may not be a single entity, but a combination of multiple forces, including the strong force and the VEV of the Higgs field. They believe that these forces, along with the other fundamental forces of nature, create a kind of web that connects everything in the universe, It's like a cosmic dance where each force plays a different instrument, creating a harmonious symphony that keeps the universe in balance. But the mystery doesn't end there. Some physicists even suggest that this web-like structure could have a fractal-like quality. That means it would exhibit self-similarity across different scales, from the smallest subatomic particles to the largest galaxies. Imagine looking at a piece of fabric and seeing the same pattern of threads repeating themselves over and over again, no matter how much you zoom in or out. That's the kind of fractal-like behavior that some physicists think could be happening on a cosmic scale. It's as if the very fabric of the universe is woven together in a tapestry of forces and particles. But why would the universe have this kind of structure? What's the purpose of this cosmic dance? Well, one idea is that it's a reflection of the underlying order and simplicity of the laws of nature. Physicists often strive to find the simplest possible explanations for the phenomena they observe, and a fractal-like structure in the universe could be a manifestation of that underlying simplicity. Think about it. If the universe is a vast, complex place, why not start with a simple, elegant structure that can be scaled up to fit everything we see around us? Another intriguing idea is that the fractal-like structure of the universe could be a consequence of quantum fluctuations. Quantum mechanics introduces an element of randomness and uncertainty into the behavior of particles. These random fluctuations could give rise to the complex patterns we see on a cosmic scale. Much like a butterfly flapping its wings in China can cause a tornado in Texas. It's a reminder that even in the seemingly chaotic universe, there may be underlying order and connections that we're only beginning to understand. As we continue to explore the mysteries of the cosmos, we may uncover even more fascinating insights into the force that holds it together. Who knows what other secrets the universe is hiding? What do you think about the force that holds the universe together? Are you amazed by the power of the strong force or intrigued by the idea of a Higgs field? Perhaps you have your own theories about what could be connecting everything in the universe. No matter your thoughts, remember that the most extraordinary scientific discoveries often begin with a simple question. So keep looking up at the stars, keep asking questions, and keep exploring the wonders of our universe. If you enjoyed this journey into the unknown, don't forget to stay tuned for more videos like this, to bring you the latest and greatest from the world of science, technology, and innovation. Also, if you found this video helpful, please hit that like button and share it with your friends. Your support means the world to us. Now, go out there and keep asking questions. The universe is waiting for you to discover its secrets. Thank you for joining us today. Till next time, keep looking up.